Now, suppose I ask you to find the absolute minimum and absolute maximum of a function. So this is an example for you. So far, we learned how to find the local ones. Now we want to find the absolute ones. Find the absolute minimum and the maximum of the function f of x and y equals to x squared minus 2xy plus 2y on the given domain. So I'm going to restrict the domain. Just look at some part of the domain, which is defined as a set of all points such that x is bounded between 0 and 3, and my y is bounded between 0 and 2. So it's actually a box. So here you have a box which can be graphed this way. The part of the domain. X is bounded between 0 and 3. X is equal to 0, x equals to 3, and the y is equal to 0, y equals to 2. So here you're going to have your y. So you're looking at this box. This is your box. This box here. This is D. I want to know what are the maximum, absolute minimum of this function over this box. Well, let us begin. First, let's find the critical values. The same as before. We're going to find the partial derivative of f with respect to x and set it equal to 0. Partial derivative of f with respect to y equal to 0. So f of x is going to be 2x minus 2y equal to 0. And with respect to y, negative 2x plus 2 equal to 0. Very good. So by solving the second equation, x is 1. So when x is 1, y is 1 as well. So just substitute this here. The only critical point is 1 and 1. Just note that if you want to form your Hessian, you get the following. This is d f of xx, f of yy minus f of xy to the second power. So f of xx, the second partial derivative with respect to x is 2. The second partial derivative with respect to y is 0 minus. Then if I take the partial derivative of any of these constants, it's going to be 0. My d is 0. It doesn't give me any useful information. My Hessian is equal to 0. So we have to use the nearby points. But in that case, our domain is restricted to this box. This is x equal to 3, y equals to 2. So I need to work with the boundary points. So let's see. D is 0. So we use the points on the boundary of the box. Very good. I'm going to graph this guy a little bit larger so we can define the boundary on this box a little bit easier to see. So here I have my box. This line is x equals to 3. And this line is y equals to 2. Very good. So now take a look at this. You have 1, 2, 3, 4 boundary lines. Am I right? Let's call it, for example, L1 and L2, line L3 and line L4. These are the boundaries which are written in line forms. On L1, we have the following scenario. Take a look at L1. Your y value is equal to 0. Y is 0. This is from algebra, nothing new. Y is equal to 0. So take a look at your function. F of x and y is equal to x squared minus 2xy plus 2y. F of x and 0 is x squared. Guys, I reduced my function to a parabola. Am I right? Elementary calculus. Note that your x is bounded between 0 and 3. Okay, so what's the maximum value? It's going to be 9. X is bounded between 0 and 3, and f of 3 is 9. F of 0 is 0. Okay. So on L1, this is the behavior of your original function. On L1, this is the behavior of your original function. Now, let us move on, for example, to L2. Okay. Analysis on L2. What's the behavior on L2? On L2, your x is equal to 3. My x is 3. So I'm going to go back to my original function. X is fixed, x is 3. F of x and y is, here you have, let's write down the original function again, so you can follow 3 and y is going to be 9 minus 6y plus 2y, which is 9 minus 4y. Just a line, 9 minus 4y. And note that your y is bounded between 0 and 2. Okay. Very good. So if you plug in 0, you get f of 3 and 0, which is equal to 9. If you plug in 2, f of 3 and 2 is equal to, here you have 9 minus 8, which is 1. Very good. It's just a line, the behavior of a decreasing line, the maximum and the minimum. The same for your parabola, the maximum and the minimum. They're just coming from elementary calculus. Now on L3, this line. Okay, my y is fixed and my y is equal to 2. Again, go back to the original function. F of x and 2 is equal to x squared minus 4x plus 4. Again, you have a quadratic function. Well, for this quadratic function, what do we know? We know that x is bounded between 0 and 3 from the box itself. We have restriction on x. So just plug in 0, f of 0 and 2 is equal to 4, and f of 3 and 2 is equal to, here you have 9 minus 12 plus 4. You get 1. Okay, perfect. So far, so good. And finally, on L4, my x is 0. That's obvious. X is 0. So f of 0 and y, 0 and y becomes 0 minus 0, 2y. It's just a line, and y is bounded between 0 and 2. So f of 0 and 0 is 0. F of 0 and 2 is 4. Very good. So what is our maximum? What is our minimum? The maximum value seems to be 9, all right? And the minimum value seems to be 0. So the maximum is 9, and absolute maximum is 9, and the absolute minimum is 0. Don't forget to plug in 1 and 1. It's your critical value. So f of 1 and 1 is going to be 1 minus 2 plus 2, which is just 1. So it doesn't give us any new information. So again, the absolute maximum is 9, and the absolute minimum is 0.